Assalamu alaikum. My name is Dr. Usman Paracha, and today we would be going through our lecture number 8 of the subject Applied Quantitative Analysis and Practices. Previously, what we did in our previous lecture was regarding measures of variation, and we discussed about the various important measures which play an important role in the quantitative analysis of any business research investigation. And in this case, the four most important measures are range, variance, standard deviation, and coefficient of variation. So basically, we termed this thing as the second phase of quantitative analysis investigation, because in first phase we have to go through the central tendency measures as a standard procedure, so that we should get to know about the characteristics of data set. We should get an initial view of the characteristics of the data set. So once we have gone through that, then we move to our second phase. Now, the second phase comprises of the measures of variation, which we discussed previously. Now, here also we had a look at the application of these tools in SPSS, and we went through the various tools and techniques through which we can get these measures results displayed, and that is a very important factor, because now we cannot manually calculate very large data sets, though the formulas for such measures of variation are there, but now for large data sets this is not possible to calculate such measures manually. So we do need the aid of a software to calculate such measures. So going through briefly how and what were the measures we discussed before. The standard model which was discussed was related to the measures of variation. As you can see that the four types here depicted in the diagram, and here you can see that all these four are related to the variation or the dispersion of the data. And here the important thing is that this whole dispersion concept and variability concept is calculated by taking mean of that specific data set as a reference. So once we take that mean as a reference, so we try to find out how much the data is spread around that mean, and based on that calculation normally all these four different measures are calculated. Now this measure of variation gives us some very important information, and though at some point central tendency measures cannot give us a true picture, as you can see in this diagram that there are two curves with the same mean, but they have different dispersion, they have different variation. So in order to identify the difference and to know additional details of the data set, it is important that these measures of variation be calculated. We also know how to use that in SPSS, and basically the testing is being made in SPSS based on the model which is shown here. Again, just for the understanding, these are the 6 human resource management practices whose impact we are trying to find out on employee attitude and behavior, also termed as organizational commitment. So based on this factor, here we have tried to calculate all these, and now as we have studied the measures of variation, we tried to see that through how many different ways we can calculate these measures of variation in SPSS. So going to the software, and here you can see we are just seeing the same variables we discussed before, and the data set has been entered here with the respondents' values entered basically in regard of every question. So here going to the transform part, because additionally these measures of variation can be calculated through another tool as well. And going to, if we click on the transform button in the menu bar, just click on the compute variable option, and here you can see a dialog box which we have seen in the previous presentations. You can see and you can calculate these measures through the same procedure. Let's say here, let's define a target variable, which is let's say training, and we want to calculate the standard deviation. So let's say it's or in other words, it's TR and ST representing standard deviation of training variables. So here again we can mention the type and label, and here the label can be written as training standard deviation. Clicking on continue. So now we can select all the function groups by clicking on all, and here below this function group window we can see about different values, and let's see where is the standard deviation. Here you can go in the S category, and here you can see a function termed as SD. So clicking on SD here, you can see the detail of that function appearing in the window, and SD basically here represents the returning of the standard deviation of its arguments that have valid non-missing values. So let's enter this function in the numeric expression by clicking on the arrow, and now we have to give the variables of whom we want to calculate the standard deviation. So by clicking on TR1 and clicking on the arrow here, it's included in the numeric expression, and then again by clicking on the second variable, which is TR2, and clicking on the arrow, this second variable is also added. Now as we want to know the standard deviation of all the 6 questions related to training variable of a single respondent, so we will keep on adding these different variables in this numeric expression. So we click on comma, and we select the third variable of training and click on arrow here again, then again clicking on comma and selecting the fourth training variable. Likewise by clicking on the comma again and selecting the fifth variable and the sixth variable, training variable here. So once we have selected all these, we can click on OK, and here let's have a look at the end column, and you can see that a new variable has been added whose name is TRST, representing the training variable with standard deviation, and the standard deviation of all these variables have been reported. So this is another way of trying to find the standard deviation or any measure of dispersion. Likewise, you can find out other functions as well. For example, you can go to transform, you can click on compute variable, and just roll down the functions window, and let's have a look if we can find out the variance. So variance here can be seen, and again we have selected this. So first let's delete the older numeric expression and make a new target variable. We save it as TRVAR, which is variance of training variable, and the label of that variable can be changed to training, and it's termed as variance. And by clicking on continue, now let's select variance and select the arrow. Now again we have to enter all the various variables, and by clicking on training TR1 we select this one, and likewise we select the other variables and include it here. Now clicking on comma and selecting TR3, then again comma and TR4, likewise TR5, and here again let's first put comma here and then select TR5, then it's TR6. So now we have selected all the training variables here, and we want to calculate the variance of these variables. So by clicking on OK and going to the last column, we can see that another variable has been included, and the variance of these set of variables have been reported here. Here the variance is then displayed. Now if we want to calculate other functions, we can similarly follow the same procedure by clicking on transform and clicking on compute variable. Here you can see in the list other functions as well. For example, range, which is shown here. I have highlighted this in functions and special variable group. So you can calculate the range or set of variables from the same formula, and by following the same procedure we have just done for other variables as well. And similarly, if we want to calculate the coefficient of variation, then we have the facility of calculating that by clicking on CFVAR. And here I have highlighted this. You can easily see that the coefficient of variation function is available here, and you can enter this in numeric expression, and by entering the rest of the values of any variable, as we have entered the training variables, all 6 of them, you can calculate the coefficient of variation of any variables here by entering them here in this case. So this is another example of going through the calculation of measures of variation. Now once we have gone through this exercise, you must have remembered that we also had an example of how to use contingency tables to display the data more effectively, to find out the hidden dimensions of the data which may not be visible through clear-cut time trends or through normal data made available to you. So contingency tables are made, and in this case we will try to see how to make contingency tables, plus how to recode these existing variables into different variables. So in order to do that, we open up another data file, and going to this one, let's see on the screen you can see another file which comprises of some data whose variables you can see in the columns. The first variable is the gender, then the second is the year, we have got class. Now here app APP here represents the number of students who are appearing in board examination. Then is the next column which is designated as pass, and it represents the number of students who have passed the board of intermediate and secondary examinations specifically related to matriculation. Now the next column represents the percentage, the pass percentage, and then is the field related to area. Now here the next is related to performance or percentage groups. Now percentage groups basically represent the various percentage cohorts in which the percentage is divided. We will discuss this later. Just going to the view button in the menu bar and clicking on value labels, we can see the details of the coding which has been entered, and here you can see that every case, let's say in the first row and so on, all these cases represent an individual school, and the gender represents that it's a male government school, and the result is of the year 2000, and the class whose result is being displayed is 10th class. So this is the initial information we can get from the list of variables which we can see in the column headers. Now what we want to do is we want to create this percentage field and convert this field into another one in the form of groups. Now here you can see that such type of groups have already been made, but just for the sake of learning perspective, we will convert this percentage information field into different groups again. What we want is that we want to identify certain groups who have certain limits, like one group may comprise of results which lie in between 0 to 30%, and in fact, in other words, it represents those schools who report the result in between 0 to 30%. So in order to do that, we have to in fact recode this basically variable into different variable. So first what we have to do is to click on transform, and as we want to recode in this variable into different variables, so here there is an option within this drop down menu which states recode into different variable. Now here we have got additional option that we can recode this percentage variable into the same variable, but in that case the same variable, that is percentage field, will be converted into groups and our original data will be lost. So in order to avoid that, we can use the other option which is related to the recoding of the variable into different variables. So let's click on this one. Now here you can see that we have to first identify the input variable which we want to record. We want to record here pass percentage. So we click on pass percentage and click on the arrow. Now once we have done that, now SPSS is asking for the output variable, and here the name of the output variable, let's say, is written as group percentage. So it's written in the short form as GRPER, but we can give its explanation in the label, and it's termed as percentage group. So we push the change button, and now we have given the information that this percentage numerical variable is converted into output variable in this case. Now by clicking on old and new values, we have to define the criteria based on which the existing field of percentage is converted into different other groups. So here one option is that we just state here a certain value which will be converted into new value, which you can see on the right column under new value. That's one method. Then the other is related to system missing. Now here basically is that those values which are missing in the system can be replaced with some new value, and a new variable will be created. Or you can identify system or user missing, those values which have been entered, which have not been entered by user or have been due to some flaw of the system. So those missing values can be replaced with the new value which you want. Then you can also give the range here from a certain value to another value, and that range will be converted into the new value which is stated here. And then we have got another value called range lowest through value. That means that the lowest value in the whole data set, and from that lowest value to the value which you will state here in this cell will be converted into the new value which you will state later in the right hand side. Similarly, there is another value called range value through highest. It's the opposite of lowest through value, and here we will enter a certain value, and the SPSS will start from that value and end up with the highest value in the data set and convert this into the new value which you want. So here I want to create some different cohorts. So here I first start with a range lowest through value. So lowest, whatever it is, to let's say 29.999. So that means that in percentage, those percentages which are the lowest up till the highest value of 29.99 should be converted into a new value which we can enter into the new value cell. So here we can denote this value as 030, which can represent those groups with 0 to 30 basically group, and we can click on the add button here, and here a new group value has been defined. So in order to define the other values, we can go to the other option, which is range, and by clicking on here another group, let's say we make another group ranging from 30% to 60%. So the starting point is the 30%, which is written in the cell here, and it can be moved to 30 to 59.999, and this group which is representing the pass percentage from 30 to 60%, in fact, is written here as 3060, which represents 30 to 60% group, and we add this value here. Similarly, in order to add other groups, we can define the range from 60 through 59.999. So here again, this range can be, sorry, this is 60 to 90.999, and this can be termed as the new value as 6090, and we add this new value here as well. Then from 90% onwards, we can click the range value through highest, and that is 91 through highest is termed as 9010, which will represent the group ranging from 90 to 100%. So we add this new value again here, and by clicking on continue, this new group has been defined, and the old variable now will be converted into a new variable termed as GRPER, which represents the percentage group. So by clicking on OK, you can see that a new variable has been added, which basically represents the grouping under which the school's percentage has been divided and represented by these groups now. So once we have done that, now we can easily form the table which we discussed in previous examples. So going to Analyze, going to Tables, we click on Custom Tables here, and we click on OK. And in columns, we just want to be shown the year of passing, so we just have to click on the variable on left hand side and drag it to the columns, and you can see now that the year and the count is visible. Count means that the number of cases would be reported which are under these various groups. So let's drag the percentage group in rows, and once the information has been inculcated here, we can click on OK, and we can see the results here. So here you can see that it is showing the mean of all these percentage groups here. Similarly, we can show multiple information in this table by going back to the Analyze and going to Table and clicking on Custom Tables. By clicking on OK, we can see here that the mean basically is presented, and we can additionally ensure that information other than mean can also be presented in this table. So we just click on percentage, and you can see here that a button here is highlighted which is under Define, and it's related to summary statistics. So by clicking on it, another dialog box opens, and basically here we have to mention what kind of statistics we want to report of the related variable here. So we click on Statistics, and we don't want to see the mean now, so we click on the back arrow, and the mean has gone back to the column. So we want just to have the counting number, and we can click on the arrow in order to place it there again. Similarly, you can try to find out many information related to this percentage variable or any variable which you want, and it will be displayed under the columns. So we would just click on the count and then click apply to selection. Once this selection is ensured, you can see that the percentage count is now appearing here. So by clicking on OK, we can see the count is now being presented of these variables here. So basically the tables can be generated through many ways, and they can depict many different information regarding that specific data set. This tool is very effective in elaborating different information related to the variable in a more effective way. So now coming to the next issue, that is related to our next topic, which is ZScore. And basically ZScore again is very effectively used in our quantitative analysis. In fact, most of the values or data values are preferably first converted to ZScore and then they are used for analysis. Now you can see that in order to compute this ZScore, all what we have to do is to subtract the mean and divide the value with the standard deviation. Now basically this represents the number of standard deviation the data value is away from the mean. So basically higher is the standard deviation or higher is the Z-score, that means the farther the value is from the mean. Now there are some extreme limits which have been determined in this case, and we say that basically if the Z-score of a specific data set is greater than 3 or less than -3, then that means that that data value is very much extreme value and it is considered as an outlier. So that means that again our greater values of Z are not much desirable. So here going to the next part, you can see the formula for Z-score, which is represented by Z, and it's equivalent to the X, which is the data value, minus the sample mean X bar and divided by the standard deviation. This is the standard formula to calculate the Z-score of any data value. So going ahead with that, there's just an example that let's say if we have got a mean SAT score of 490 and with the standard deviation of 100, we have to calculate the Z-score. So all what we have to do is to put the values in the Z-score formula, and we get the value of 1.3 standard deviation above the mean. Now basically we have defined the limits, the higher and lower limits of Z-score, and this is vital that this Z-score is below 3 and -3 in this case. Then Z-score calculation again also helps us identify the outlier value immediately, because all what we have to do is try to find out the Z-score of that value, and we can come to know instantaneously whether that value is an outlier or not. Now this is specifically helpful when you have got a data set, a big data set, and the values have been entered and the Z-scores have also been entered in another column, and all what we have to do is just go through the Z-score values of those original values and try to find out if any value is above or below 3 or -3. So that basically helps us in determining the outlier without going through the histogram practice or without trying to display the histogram of frequency distribution chart so that we can come to know about these outliers first. So basically when we go through this z-value is very important. So how to calculate the z-value in SPSS? So going to back to the software, here we have got the same chart and same values, and we just want to calculate the z-value of first question of training. So how to calculate that? So just clicking on Analyze button and clicking on Descriptive Statistics, we can select Descriptives, and from there we can first select the variable of whom we want to find out the standardized values or z-values. So we just click on training variable 1, 2, 3, and we just enter them in variable portion. Now there's a specific option below this drop down menu which is stating that save standardized values as variables. So basically we have to click on it. It means that SPSS will basically not only report these descriptives but also give us standardized values in the form of variables. So we just click on OK, and if we go to the end column, we can see that additional 3 variables have been created, termed as ZTR1, ZTR2 and ZTR3. What SPSS has done is that it has converted all the individual values into z-score of that respective variable, and all what we have to do is just to have a look at each individual value. If we find out that any individual value is above 3 or below -3, then we can term such value as outlier. So it makes our job more easy, because when you have got large data sets, so sometimes if you want to know whether all the values are within normal limits, so all what we have to do is roll down the list and just have a look at the z-score of these values. Once we have gone through that, then we can also have a list of values which are specifically outliers and which may be disturbing our result. So this basically z-score is very much effective in identifying the individual values who have abnormal values in this case. So once we have gone through that, we can try to find out the z-score of any number of variables we want. Z-values are very important in this aspect that they give us a true picture of the data set, and also are helpful in identifying the outliers. Plus also from these values, once they are calculated, we can compare the z-values of any kind of variables, no matter how different they are from one another. So that is one effective tool to make the variables values comparable to each other. So once we have calculated these from this, then these values are then used in advanced calculations, advanced analysis, and thus are helpful in going ahead in this case. So coming to the next topic, which is related to the shape of a distribution. It gives us how the data is distributed, first of all, and basically the tools which are used to describe the shape of a distribution are called skewness and kurtosis. Now skewness basically represents the way and the extent to which the values are not symmetrical in this case, and kurtosis basically gives us the peak of the curve of the distribution. So basically it's more related to the curve of distribution, that how much it is at peak here. Now both are commonly reported, and here we are just giving you a few examples of skewness. And let's say in first case you can see that if the mean of a certain data set is less than median, then we have got a curve whose picture is depicted in this graph, and such a graph is termed as left skewed. Now if on the other hand we have got mean and median both equal, then this is kind of a very ideal situation, which is also called symmetric distribution. Then on the right side we are seeing right side skewness issue, and in that case basically mean is greater than the median, and if that is the case, then the curve which is formed is termed as right skewed. Again, here the skewness statistics basically reported is less than 0 in case of left skewed, and then in case the value is reported greater than 0, then such a data is right skewed. Now coming to kurtosis, basically it gives us the information related to the fact that how sharp is the curve rising and falling, and we are seeing 3 different types of curves, and in these basically the topmost curve with the most sharpest peak is termed as leptokurtic. Then the middle one is termed as mesokurtic, and the last one is termed as platokurtic. Now in all these 3 different situations the kurtosis value varies, and for example in the topmost in leptokurtic the kurtosis value is greater than 0. In the middle one, however, the kurtosis is termed as equal to 0, and ultimately the same thing is termed as less than 0 if we have got a curve which is more like flatter to the surface. So basically these are examples of different types of kurtosis. Now coming to the more additional detail under the descriptive statistics part, one important topic is termed as quartile measures. Now basically quartiles, as you can see here, are split basically and have got 4 segments, and equal number of values are there per segment here. So basically in each quartile there are 25% of the data set, and that's why in total there are 3 quartiles, and each quartile is represented by the separation bar which is presented here, and basically the first quartile is showing and representing the first 25% observations or smaller, and basically the 75% of observations which are larger. In second quartile it's the middle quartile, and then it represents the 50% of the data set and is nearly same as that of the median. In the last quartile, again it represents those 25% observations which are greater than the third quartile. So once we have represented the quartiles, the question is how to calculate them, and here the calculation of quartile can easily be done through the formula which is written as, let's say for first quartile, it's Q1 is equal to n plus 1 divided by 4. And likewise then for central quartile it is n plus 1 divided by 2. In the last quartile this whole formula changes, as it is termed as 3 times n plus 1 divided by 4. So these are the various ways through which we can calculate the various quartiles manually, and here n is defined as number of observed values. So basically there are certain rules in order to calculate the quartile bias, and then the first rule, as you can see here, that if the result is a whole number then the ranking position should be used. But if the value is kind of a fractional half, then we have to take the average of the corresponding two values. And if it's not a whole number or a fractional half, then the result will be rounded to the nearest integer in order to find out the rank position in this case. So here this is just one example of how to calculate these quartile bias. We can see here a set of values ranging from 11 to 22, and the first quartile is calculated by inculcating the values in the formula, and as the number of values here are 9, so we put 9 in place of n in the formula we discussed, and it then is termed as 9 plus 1 divided by 4, which is equal to 2.5. Now this 2.5 represents the position of the rank data and is not the actual value. So basically the Q1 here, which would represent the 2.5 position here, is in between 12 and 3, and so by taking the average of 12 and 13 we can get 12.5, which is basically the first quartile. So coming to the second quartile here, you can see that the formula is a bit changed, which is equal to n plus 1 divided by 2. Now here, as n is 9, we put the value of n here, and then we find out that the value which would represent this quartile is in the fifth position, and in fifth position we can see that Q2 is the median, which is 16. So in this way we calculate the middle Q2 value, and likewise in terms of Q3 we can see that the relative position of that data can be calculated. Here it is 7.5, and the 7.5 position basically comes at 19.5, because it's coming in between 17 and 18. So by taking the average we can easily calculate Q3. So once the quartiles are calculated, then it's easy to calculate the interquartile range. Now interquartile range is in between Q3 and Q1, so it can also be calculated by taking the difference between Q3 and Q1 as it's shown in the slide. And basically it's the major portion which is spread, and it's the middle 50%. So it covers the middle 50% of the data, and this is a measure which is normally not affected by outliers, because outliers either lie at the lowest extreme or the topmost extreme, as interquartile range is lying in the center and it is representing the 50% values at the center. Therefore this interquartile range basically is not much influenced by extreme values. So again, measures such like this, which are not affected by outliers, are also termed as resistant measures here in this case. Now this can be evident from one example which is shown on the screen, and here you can see a certain data set which ranges from 12 to 70, and by putting the values which we have done before, we can see the various values of Q1, Q2 and Q3, and also the interquartile range. Once Q1 and Q3 have been calculated, they can be calculated by simply subtracting Q3 from Q1. So coming to this, we have got here the interquartile range of 2 to 7, and thus there is a simple summary, and in this case the spread and shape of the data can be described as the smallest value of x, then comes the first quartile, and then comes the second quartile, which is also termed as the median, then comes the third quartile, which is Q3, and then is the last is, but not the least, is the largest value of x. This is the 5-number summary which can be explained here, and a technical technique which is used to display these quartiles is termed as box plotting. And here you can see the graphical diagram of the box plotting, which is evident here, and in this case you can see the smallest and largest value, and Q1 and Q3 as well. Basically the box plot is in this form, in which you can see some minimum value as basically bar, which is shown here on the screen as x smallest. Then the Q1 boundary starts from this part, which is represented from Q1 here, and then we can see the middle median part, which is shown here, and then we are dealing with Q3, which is again evident at this side. The largest value is the other extreme, which is shown here, and basically box plotting gives us a kind of a complete picture that where are the quartiles lying in a certain data set, and their location in the left side or right side also tells us the spread of the data and where is it is lying, whether it's lying on higher values side or whether the majority of the data is on the lower value side. So box plotting is very effective in giving us such kind of vital information. So let's come to the summary of this lecture. So today what we studied about was related to different methods to calculate various measures of variation in SPSS and how to use compute variable function in SPSS software. Then we went through how to recode different variables into different forms and how that recoded variables can be used to display contingency table, and how to use different information or different measures of variation in contingency table in SPSS. Then what we discussed about was related to Z-score. What is a Z-score, what is its importance, and how basically that Z-score can be calculated, not only manually but also how it can be calculated in SPSS. Then we had a discussion about what is the shape of a distribution and what would be the case if median is less than mean or median is greater than mean, and then what are the two basic measures through which we can see the shape of distribution, which are skewness and kurtosis. Then we discussed about the various quartile measures and how these quartile measures are basically calculated and what is their significance, and how these quartile measures can be displayed in the form of box plotting. So this was enough for today. Thank you so much. Allah Hafiz.